Hello and welcome to CIC Start Online webinar here at Glasgow Caledonian University. My name is Branka Dimitrijević and I will moderate today's event. Our seminars and webinars disseminate outcomes of feasibility studies and academic consultancy undertaken by 7 universities involved in our project and Scottish small to medium-sized enterprises. These studies focus on innovations for sustainable building design and refurbishment. The project is funded by European Regional Development Fund and Scottish Government CIC program. Before introducing the speakers, just usual housekeeping points. If there is a fire alarm, we will have to stop this event and we will resume later. But if you cannot join us, then of course you can watch video recording, which will be published in a few days. We plan to finish presentations around 1:30. Online audience can start using chat facility now to ask any questions during the presentations, but the answers will be provided at 1:30 when our Q&A session will start. The event will close at 2 o'clock. So, the title of today's webinar is Energy Efficiency Improvements in Tenements in Bros-Williamson in Glasgow. This feasibility study was undertaken by researchers at Edinburgh Napier University and in collaboration with Lanarkshire Housing Association. The speakers today are Julio Bros-Williamson of Edinburgh Napier University and Gavin Young, Technical Services Manager at Lanarkshire Housing Association. I would now kindly ask Julio to start his presentation.
Thank you very much, Branka. And I'd like to thank yourself and the team for this opportunity to conduct this webinar and also the research. And also Gavin Young from Lanarkshire Housing Association for obviously providing information and taking part in this study with them. As you the study itself, feasibility study into energy efficiency improvements in tenements in Bells Hill, which is a town in North Lanarkshire. Quite an important topic in terms of dealing with energy efficiency and energy solutions in older properties and hard to treat properties. I would like to just go through a bit of the contents in this presentation. It will be conducted both by myself and Gavin Young, and I'll start with a bit of introduction and a brief and what the work is all about. Gavin will then continue on talking a bit about the Housing Association and some of the constraints that they have and some of the expectations from the study. And then I will retake the presentation and explain a bit about the methodology of the work and the report, and obviously the work that was conducted, and some of the alternatives and solutions that we came up with. Throughout the work, there was a lot of debate with the association, the Housing Association, and the research we were doing, which was very healthy in terms of coming up with solutions. Gavin will then wrap up in terms of some conclusions and some of the Housing Association expectations from the study and the use of the results. And then I'll conclude with some of the conclusions from the study in terms of the report. As it was mentioned before, the feasibility study was between Lanarkshire Housing Association and Napier University, Edinburgh Napier University, and the Scottish Energy Centre, which I am part of. We deal with a great deal of similar projects in terms of hard-to-treat buildings, and also to do with energy and renewable energy solutions. In this particular project, we're dealing mainly with fabric intervention and different alternatives on energy, and most importantly, dealing with fuel poverty and how we can reduce that in housing. We'll be looking especially at tenemental buildings in the town of Bells Hill, and it's a cluster of different flats and buildings that are in particular in need of upgrading, especially in the energy side of things. There's throughout the report and a lot of the findings looked at social problems and how to interact to some of the solutions with the different users of the properties. So that will be something that is part of the study. The feasibility study addresses the issues of improving thermal comfort for the people using these tenements, these flats, but at the same time looking at a cost-conscious way of delivering some solutions and alternatives. As I mentioned before, fuel poverty is a big topic, especially in the social housing sector. Where most of these apartments are occupied by a key group, which we refer to as people who are unemployed, people who are retired with very low pensions, single mothers, or very young couples, first-time buyers, for example, or first-time occupiers of properties. So there's different circumstances that surround this. The tenancy, different mix of tenants. The clear aim of the study was really, as I mentioned, to increase thermal comfort and to come up with methods that are efficient, both economically and technically. All of these solutions can really be solved on having more efficient ways of heating the dwellings, but also looking at interventions in fabric of most of these apartments. And there's lots of constraints in terms of installation of new energy solutions and technical solutions as well. So that will be quite an important factor in the study. The objectives, looking and understanding of energy efficiency in these hard-to-treat buildings, looking at fabric essentially, also looking and discussing different constraints for the heating services, both for space heating and water heating. Looking at reducing fuel poverty with energy efficiency, and also looking at the economical constraints with these new alternatives. I'd like to pass the microphone over to Gavin Young on a background of the Housing Association.
Thank you. You'll see from the slide that Lanarkshire Housing Associations are a fairly typical community-based housing association with about 830 rental units concentrated in Motherwell and Bells Hill. It's a varied stock with a mixture of flats and houses and includes about 170 older style stone fronted tenements, most of which were rehabbed in the 1980s or early 90s to the standards that were required at that time. Our most significant current programme is now a rolling programme of work replacing elements in this stock when it reaches the end of its planned lifespan. So, for example, electric heating would be replaced after 15 years, kitchen fittings after 20 years, and so on. And this all has to be funded from the association's rental income and financial reserves. Again, in common with most of the community-based housing associations surrounding us, we're financially fairly well set up to meet this commitment. There's also a wider policy context that we operate within, and that is what the Scottish Government requires housing associations to do to the stock, which is currently set out in the Scottish Housing Quality Standard, or SHQS, and that's their minimum standard for all social rented housing, which has to be met by 2015. And in addition to that, we would anticipate in the next couple of years the publication of a higher standard that will operate after that date, possibly linked to the Scottish Government's targets for carbon reduction. Before moving on, I'll say a little more about the SHQS, which has 55 elements divided across the 5 criteria which appear in the slide. One of these is energy efficiency, which was the focus of this study. While the energy efficiency criterion itself has 6 elements to it, addressing the standards of insulation and heating system in a house, the key is really the requirement for a performance of NHER5 or SAP 50. But SHQS compliance wasn't the only factor from the association's perspective. We wanted a broader study carried out, addressing related issues such as fuel poverty and looking at how to provide solutions that are likely to meet tenants' needs and lead to high levels of customer satisfaction amongst our tenants. On the other side of the equation, it was necessary to establish what solutions to improving energy efficiency would actually represent value for money. Because from our perspective, any solution would have to fit into an asset management and planned maintenance programme, along with a range of competing priorities. It would have to be justified as a worthwhile use of what will inevitably be a non-infinite supply of money. The other key issue for us was possibly future-proofing any work that we carry out. That is, trying to carry out levels of improvement that are likely to meet a future standard. Well, this is obviously difficult, a very difficult question to answer when you don't yet have any firm indication of what that future standard may be. Focusing in more on the Bells Hill Town Centre and the reasons for a study of this particular area, there were a number of these. First was that the building is considered to have a long-term future, unlike some say public sector or housing association stock that has been assessed as suitable for demolition for one reason or another. Second was that our planned programme of work already identified that the heating systems in the flats were due for replacement, and our financial plans would provide for this, so that the study was going to be related to a real programme. And we also knew that a like-for-like replacement of the heating systems in the buildings would not in itself bring the flats up to meet SHQS. We already knew that at least some of the flats would fail. In addition to those 3, there were some specific issues in the Bells Hill Town Centre building. We knew that the flats were relatively small and would have limited flexibility for installation of new systems. although they are actually, as shown by the study, by no means exceptionally small. There was also the issue of our not having complete ownership of the building, which has both other residential and commercial owners. We knew this was likely to rule out more radical solutions which would require major work to the building fabric. In summary then, what did we know about the building before the study started? Well, we knew that the heating systems were unlikely to be performing well. We also knew that the overall energy efficiency rating of the building was unlikely to be good. We anticipated that this, along with some related issues, was probably going to be reflected in the level of tenant dissatisfaction. What we also knew was that what we'd been able to do in the past, in some similar, or broadly similar buildings, to overcome those issues and bring stock up to the SHQS. And that was namely to upgrade the insulation where necessary and put in a new gas heating system with a condensing combi boiler. On the other hand, what we didn't know were a number of key things which we wanted to find out from the study. First, we lacked a detailed understanding of the building fabric's performance. Second, we didn't understand the relative significance of building fabric performance and the standard of heating systems, their respective contributions to the overall energy rating of the building. Following from that, we wanted to know about the relative costs and benefits offered by a range of solutions, both in terms of fabric improvement and system upgrades. And we wanted to assess the feasibility of different solutions given the realities of having to work in a building with multiple ownership. I'll hand back to Julio now to deal with what we learned from the study.
I will continue with explaining a bit of the current state of the buildings. They're, as I mentioned before, located in North Lanarkshire in the town of Bells Hill. They're typical pre-1919 tenements of the region with red sandstone solid walls. Most of them internally have plasterboard linings. Built, at the back of the buildings, they have most of the staircases, the adjoining staircases and back walls are stone rubble and rendered with a harling or a pebble stone finish. And the roofs are typical timber structure with slate external finish. This is a kind of bird's eye view, a view of the different apartments. As we can see, they're on a cornered location with we've got Hamilton Road on the main street and Main Street in the corner, and we've got a more densely packed set of apartments on Hamilton Road than on Main Street. There are ground floor commercial units in all of the apartments, and a first floor and second floor of apartments. A lot of issues on the backs and the areas behind the apartments, where there's a common area used by the commercial units, by the shops, for parking, for storage, and there's a bit of kind of debate on ownership issues on that, whether it's for the tenants or for the commercial units. These are images of the front elevations. The top image is for Hamilton Road, and the one below is for Main Street. As you can see, the commercial units in ground floor. The selected windows and flats are ones that were taken further in the analysis of fabric intervention and energy alternatives for this study. These are the back elevations. The first two at the top are for the apartments in Hamilton Road. As you can see, there's a lot of infrastructure from the commercial units in ground floor in combination with the staircases and the external render, Harling render. The two images below are the one on the left are the different staircases belonging to Hamilton Road, and the one on the right is for Main Street, the main staircase for those apartments. In terms of the interiors, most of the staircases that I showed in the previous slide had some traces of dampness. The render, the external render, was in some areas falling off. Moisture was kind of acting there and becoming quite an issue. The stair landings are in general good state and lead to 2 apartments on each level. An external storage room is located on these landings, but mainly on the Hamilton Road apartments, where you've got 2 areas for storage and different ducts for services around the building. The majority of these apartments have plasterboard interiors, as I mentioned before, and ceilings as well. And most of the top floor apartments or flats, there's insulation on most of them, but very minimal. In average, a 50mm mineral wool is located in these ceilings. And in terms of the finishes, I mean, most apartments have carpets, floorboards, over floorboards, and are quite basic interiors. These are some images of some of the apartments and their interiors. Most of the apartments, I would say nearly 100%, are double glazed units with timber frames. As we can see, the main corridors and hall areas are quite dark areas where that can be quite narrow and cluttered. And the last image is a view of these storage units and storage rooms in Hamilton Road apartments on the landings. Some more images of the bathrooms, the living areas, and the kitchen. Kitchens are quite small, and a lot of their appliances are electrically based. Moving on to the energy mix and how most of these apartments are heated, as Gavin was mentioning, the majority of the apartments, their energy supplied by electricity. No gas installations are available in that at present. All the kitchen appliances are electric as well. There's storage heaters and night heaters throughout the apartments, for space heating, that operate with night storage and use a lot of the night tariffs, electrical tariffs, to store up and release heat during the days. A lot of these radiators or storage heaters are quite inefficient and not performing as well, and some of them are not in operation at all. So in that case, a lot of secondary heaters are being used, different electrical heaters and different means of space heating, which are quite inefficient and are quite costly to run. In terms of the water heating, there is a storage tank in one of the storage rooms inside the building, inside the apartments. and each storage tank has a 3 kilowatt immerser heater, which in general terms takes a long enough time to heat up the core of the water inside the tank, so can be quite inefficient at times. So in a way, fuel poverty is quite an issue. A lot of the tenants are having to spend a lot of their income on heating, and not necessarily very efficient. These are some of the images of the current heating. We can see the storage heaters. Some of them, because they're not being used, are kind of put to one side and are blocked in some cases. In kitchens, there are some alternative heaters, electrical again. So that's quite predominant throughout the apartments. In terms of the water heating, we can see some images of the water tank, some examples of alternative heating devices, which are quite predominant in a lot of apartments, and some other electrical heaters. In terms of the methodology of the work and how we conducted the study, the options really that we were focusing on, as I've mentioned, is fabric intervention and alternative energy sources for space heating and water heating. There's a great deal of alternatives that we explored, some quite costly, some more mainstream, I would say. But with some interesting results, which I'll mention later on. The way we engaged into fabric intervention is by conducting a simulation using a dynamic thermal simulation software called SciMap, produced and developed by CADline. And the way this software operates is by obtaining current energy use of the building through electrical bills in this case, and trying to model using a floor plan in a two-dimension way, and indicating the different materials and different fabric use, the current fabric use within the selected apartments. So there's different ways of assigning the materials to the building in the simulation, which can later give us some results in terms of energy use. Once that was obtained, once we obtained a simulation that was as close as the current way of use of that building in terms of its energy, we started to look at different alternatives and different changes within the fabric to bring some of the energy consumption down as best as possible. So there was ways of adding insulation into the external walls, looking at draft proofing, looking at windows, etc. We focused mainly on looking at alternatives in the fabric of the walls externally. Not all apartments were simulated from this development, but what we did was located different apartments within the two locations. So we looked at one apartment and one flat in Main Street, which is slightly different configuration as apartments in Hamilton Road. So we had those two examples, those two simulations to deal with. And we then looked at space heating and water heating alternatives, not so much in the simulation, but independently as feasibility alternatives. And we also looked at intelligent ways of bringing energy into the households, both cost effective as possible and easier as possible. And some renewables were also explored. I would say that the properties in Hamilton Road were the more flexible in terms of energy alternatives and supply of new means of fuels, for example, and technology. Properties on Main Street were more suited for renewables, mainly because of its orientation and the roof being orientated, one of the roofs, the back roof, being orientated southwards. So that gave us a bit more options in some renewables. Common areas at the back, because they were not fully owned or by the housing association, was difficult to kind of integrate into the solutions. Nevertheless, we did explore some alternatives that would engage a partnership with commercial units or with other owners of the flats to kind of bring a better energy solution. Buildings are not listed, but are kind of, in terms of planning, they have restrictions and do comply with some elements of conservation within them. There's this social inequality in terms of some people are renting, some people are owners of the different flats, so that made things quite different and quite difficult. I mean, it wasn't always easy to integrate a lot of the solutions into the apartments, mainly because of this shared ownership and difficult tenancy of the flats. So as I mentioned, 2 apartments were modelled, looking at the current electrical usage. From the energy bills that we obtained from the Housing Association, we tried to integrate that as close as possible to the simulation. Many changes were suggested, both in the simulation and as part of the desktop study, looking at draft proofing, looking at lots of alternatives in terms of energy efficiency. And both of these types of solutions were costed into the study. Part of the study also included a cost evaluation of a lot of the solutions, so that was important in terms of giving it some value back to the Housing Association. Although a lot of solutions were not explored in this study, the ones I think that we simulated were quite worthwhile, especially the ones that weren't so cost dependent. In terms of the current state of the walls, the front wall was simulated and a U value of just under 1 watt per metre squared Kelvin was obtained. This was with the plasterboard lining. And at the back wall, a much higher U value was obtained, mainly because it was a lot of plaster on the hard and not so much plasterboard integration as in the front. So there was that slight difference there. The simulation, as I mentioned before, uses 2-dimensional floor plans, and with this you can create and assign different materials on the fabric. So these are the 2 apartments. We've got on the left Hamilton Road, which is a more densely packed set of flats. They're all one bedroom apartments, small kitchens and a relatively large living area with a sitting area, etc., etc. Quite a large and long corridor as well from the main entrance. The Hamilton Road apartments had, as I mentioned before, the storage unit here, which was quite important in some of the solutions that we suggested. Main Street apartments were similar in terms of having quite a large living area at the front, and from that a kitchen as well. But in terms of the corridor and that distribution area, it was slightly smaller and less space for new alternatives to be suggested. Moving on a bit to some of the fabric alternatives that we suggested and we simulated within the SciMap model. We explored, as I said, a great deal of solutions. Some proved to be very costly, like the integration of aerogel quilt onto the different facades and elevations of the apartments. As we can see in the table, the first set of figures are the energy bills and how the building is in its original state, and then the second row of figures are the simulated set of figures. We can see that we've got heating costs and the kilowatt hours spent in 1 year, which has been taken from the energy bills of each apartment, and also the simulated ones, which try to reach as close as possible, and some of the CO2, the carbon emissions from that energy being used. So as we suggested some solutions, we could have this comparison, which was very kind of interesting to have. For example, the first one looked at the wall and the front elevation as applying aerogel, 10 millimeters of it, as a final finish onto the plasterboard, onto the original plasterboard, and at the back looking at external insulation in some cases, and also looking at insulated renders, which we then didn't kind of look into further, but it was good to simulate it as well. So we can see some of the reductions in U value, and also from that a reduction in heating costs and also in energy. The same goes for applying more layers and thicker layers of aerogel, where we go up to 30 millimeters of aerogel, and again at the back having the different external insulation. So these are two solutions that we looked at, and again a lot of energy and carbon emission reductions from the original. So this was having just 650 kilograms of CO2 savings from the original. So different alternatives, different reductions. We moved on to different alternatives, blown beads, for example, just behind the plasterboard, pumping in blown beads into that cavity, and keeping that constant of external phenolic insulation at the back, and also looking at blown cellulose fibres also blown into that cavity. So again, we explored these different alternatives, obtained different U values from them, and also looked at the different savings in terms of cost and energy to heat those apartments. We then tried to integrate a lot of the first four solutions together. So for example, having blown beads inside the cavity integrated with aerogel. Again, that would give us some more reductions, and really looking at these solutions in a more integrated way. There's some advantages, some disadvantages of each one. I mean, blown beads are quite effective and non-intrusive by just including them into the cavities, and I mean, different cellulose fibres, etc., are quite important. Again, some more alternatives with this mixture, looking at implementing phenolic insulation in the front and also at the back was also one of the alternatives, and then looking at aerogel as an element within a plasterboard backing, also taking away the original plasterboard and integrating an aerogel plasterboard back into some new stud system, etc. And then also again looking at different back elevation alternatives, looking again at aerogel and different polybead renders as well. This kind of final graph really shows some of the alternatives in comparison with the original simulation and the simulation itself. We can see that both of the original and the current simulation had some very high annual energy use and also very high CO2 use and carbon emissions. From that, we can see that from the solutions, a lot of them obviously reduce and there's a lot of savings. This graph shows mainly the savings of carbon, and we can see that from all the solutions that I just mentioned before, the carbon emissions and also the energy savings are quite well distributed. They're quite even from one another, which really gives us an indication that most of the alternatives are performing very, very close to each other. And when we come into looking at costs, that's where a lot of decisions can be made, because we can have some of the very costly aerogels performing just as well as other solutions, like the polybead and the cellulose fibre. So that's where the Housing Association could make some assumptions and look at, obviously, cost-benefit in a lot of the solutions. Moving on to the energy alternatives, there was lots of solutions out there. There's many solutions that fit different locations. So we obviously tried to integrate the best solutions for the different configuration of apartments and the location. We looked at different alternatives. For example, the first one, and maybe the more economical and quickest solution, was to carry out some remedial works to the existing storage heaters, and looking at areas where we could probably maintain and bring up to proper use and proper levels of efficiency. I mean, a lot of these current radiators are not performing or are actually not in operation at all. So maybe that could have been an alternative. In terms of the hot water, looking at ways at maybe maintaining and upgrading the current heating system is also an alternative. For example, insulating the water tank a bit better, trying to keep that heated water and retain it as much as possible. Looking at changing that immerser heater and looking at longer copper rods in terms of the immerser heater in order to heat the water quicker and more efficiently. So it would be worth checking the type of technology currently installed and maybe looking at upgrades without having to change the whole system. That would be a more economical kind of approach. Looking at a more expensive approach maybe, but probably a more efficient way also, would be to change the storage heater and substitute it with an electric boiler that can take on the use of obviously the source of electricity, which is around all the apartments, and heating water that way, and either assigning that water just for kitchen and bathroom use, or changing the space heating arrangement to a wet system where we could integrate more modern radiators, etc., and have both a water and space heating arrangement that way. The other alternative is really trying to integrate both into this electric boiler a series of seasonal regulators in terms of external climate, and trying to keep water temperatures in line with external temperatures, external climate temperatures. So by having these regulators, you can have different seasonal patterns within the boiler use, and used when and having different temperatures of water according to the use as well. And also in combination with more up-to-date storage heaters, if that was the option of leaving those storage heaters and upgrading them, having a more up-to-date and more efficient means and technology would also save a lot of electrical needs. Another alternative was to explore the way of having natural gas fed into a lot of these apartments, which would represent quite a costly investment by the housing association, but there are different ways of minimising that cost from government incentives, etc., which I'll explain. The advantage of this is that it will directly combat fuel poverty in a quite important way, as the gas costs are much lower, 4 times at times than electricity costs. So an average electricity cost per kilowatt hour is between 8 pence and 13 pence, while natural gas could be down at 3 pence per kilowatt hour. So that would be quite important. In terms of looking at the installation of this gas, the Housing Association contacted Scotia Gas networks to bring this installation into the buildings. And as I mentioned, there's some incentives there, and they have this programme called Assisted Connection, which is part of Ofgem's scheme to reduce costs and to provide gas installation to as many people as possible with lower kind of costs there. But again, that brought problems because of the different ownership of the different flats, because some of them were owned by the Housing Association and others were owned privately. That agreement would have to be obviously 100%, and that could be quite a task to bring people together. So the solution would be to bring this pipework from the main street into the apartments, into the main common rooms, and independently into each apartment. Each apartment would have its own meter and would obviously feed in from that. And then from that meter, it would supply the different gas boilers and the different appliances in the kitchen, etc. This solution would mainly benefit Hamilton Road, because when we were doing our survey, we looked at using the storage cupboards as areas where we could, in the landing, as areas where we could keep these gas boilers and any gas meters, etc. So it was a perfect area within the apartments. Each apartment on different levels had its own storage cupboard, so we could perfectly channel all the pipework into these different storage areas. Unfortunately, Main Street apartments don't have this storage area, so it was going to prove quite a big task to bring pipework into the common areas and into the apartments. Another alternative which we explored, which would have to be in combination with the commercial units and the commercial owners, housing association, and also the privately owned people, would be community heating. And I mean, this technology would give the opportunity to administer the heating services and obviously distribute them accordingly to all the apartments and all to the commercial units. Given the proximity and location of the buildings to the town centre, this alternative would bring community heating to the whole development and obviously benefit quite nicely. The plan would be to have this distribution of energy and this big community heating area at the back in the common areas of the apartments in the parking area. Yeah. So looking at areas within the back of the apartments in order to distribute this energy, whether it could be just using gas or any other renewable energy, for example, a biomass could also benefit quite nicely. It's mainly provided by special thermal insulation pipework, insulated pipework, usually installed below ground, servicing each tenement or each dwelling. And just like you would have in a typical gas installation, the installation of a hydraulic interface unit per apartment would distribute and give the different energy benefits to each apartment. So each apartment would have this hydraulic interface unit. The benefits are really that looking at the economies of scale in a primary fuel procurement and looking at the reduction in local maintenance associated with the individual gas boilers. So this kind of system would be maintained and administered by one company that would supply the whole installation. And it would take away any boiler problems, individual boiler problems per flat. So it would all be managed by this third-party person that could obviously keep it up to standard at all times. So it takes away that cost from individuals on having a yearly check on their boilers and on their system. In a better way, I mean, this system would work using a biomass supplied by wood fuel and incorporated into the system would reduce more carbon into the energy mix. I mean, however, there's lots of constraints in terms of space requirement and also looking at regulations in terms of urban setting within the technology. There's obviously the boiler cost, which can be quite expensive on its own, and also supplying the different fuels to it. The location has to be, usually takes up a large footprint, and that would have to be explored. The fuel type, there's different types of them, and obviously depending on the supply of it and the proximity of these to the location would be a big factor. I mean, there's different wood chips, pellets, and logs as well, etc. As I've mentioned, I mean, feeding this energy into the buildings can be quite expensive. Looking at pipework and ducting into them has to be explored as well. Storage of the biomass fuel is also a factor, so there's kind of space constraints. The flue is also quite an important aspect of any installation, especially where you've got different air restrictions within urban settings. There can be some problems there, which comes into a lot of the regulations depending on the setting. And also, I mean, planning is also an issue that has to be engaged in. In terms of renewable energy, we didn't look at all of the alternatives. We looked mainly at obviously the ones that we thought were quite optimum for the location. For example, wind turbines were not really preferred, mainly because of its urban setting. and the consistency of air and wind would be quite an issue. Ground source heat pumps, also, I mean, very similar to other solutions, ownership issues, complexity of installation, and in that kind of reduced site and the differences of use. We looked mainly at solar PVs and solar thermal, and we did small feasibility studies on both, as I said before, mainly on the Main Street apartments because of its orientation. So solar PVs, we looked at the feasibility study that, given the roof space and the roof area, gave us up to about 40 modules, 40 PV modules installed, which would account up to just under 8 kilowatt peak system. That would generate approximately 6,000 kilowatt hours per year, which, if we look back at some of the energy requirements per apartment, it just about supplies the electricity for 1 year for one apartment, for one flat. So because of the ownership issues and how to distribute this energy, it would have to be procured in a way that is either it distributes to all the apartments, or this energy is used maybe for communal areas, etc., etc. We would look at the payback using feed-in tariffs. Big debate over there, and the different tariffs that have been changing over the past 6 months, but nevertheless, it's still an option. A lot of the feasibility study was performed by using the PVSys software, which gave us a good indication of cost and different technology to implement. In terms of the solar thermal, in the same way we conducted a feasibility, and also we looked at the option of maybe splitting it and having both a PV and a thermal use. But after concluding and looking at all the options, the Housing Association looked at maybe the solar thermal as being the best option on its own. So we looked at evacuated tubes, and there was a good feasibility study conducted, and an estimated annual output of just under 2,000 kilowatt hours of heated water would be produced. I now hand it over to Gavin.
Thanks again. Well, at the end of the study, we looked at the options presented and the corresponding costs. I got some very interesting results. Starting with insulation, the various options explored all had very similar outcomes, but the product's costs varied by a huge factor, more than 200%. With regard to heating, given that we are already committed to replacement of the electric heating systems in the houses, the premium for installing gas is not particularly great. It's about £6,000. It's the technical feasibility of getting gas into the building rather than cost that is the main issue with gas heating. And there's the further issue with gas heating, which is that the flat's internal layouts may not lend themselves to straightforward installations in terms of where you locate boilers and root flues. There were some no-brainers which I'll obviously briefly touch on. First of those is loft insulation, for example, which it's so cheap that you're mad not to do it if you can. On the other hand, work to the windows, either replacement or upgrading of windows, is basically cost prohibitive. You just wouldn't do this work until the window reached the end of its lifespan, unless you absolutely had to get the energy rating in the building up. And there's a list here of the more high-profile sustainability stuff: community heating, renewable energy, wind turbines, ground source heat pumps. This stuff really is simply infeasible in the sort of context that we're addressing, where we would have to formalise agreements with so many different owners. Well, the two renewable energy solutions that would seem to make any sense in the context of Bellshill Town Centre are photovoltaics and solar water heating. In the case of PVs, this would be to get the feed-in tariff, which was very attractive at the time the study was carried out. In the case of solar hot water, it would be because of the significant savings that it could offer tenants, particularly in a situation where gas heating was not feasible. And if you start expressing those in terms of numbers, insulation, gas heating and solar hot water, they all offer savings in the range of 20 to 30%, but PVs offer a saving of less than 5%. So again, that reinforces the point that PVs make sense principally to get access to the feed-in tariff. But this all has to be qualified by saying there are other issues that have to be considered. Presenting the figures diagrammatically, they look like this. Here is on this slide is the cost in thousands of pounds of achieving a percentage point reduction in energy costs. And it shows both insulation and solar hot water performing well in terms of the relative cost efficiency. You can look at it slightly differently, however, on the next slide, which presents it in cash terms. And as shown here, the premium for gas, the fact that we were already committed to replacement of the electric systems, shows it to be the lowest cost option. So it reinforces the point that insulation, paying the premium for gas, or perhaps solar hot water, all seem to offer viable solutions. So where will we go on the basis of all this information? Well, we're now at the point where we know a lot about the potential energy savings and costs. What we don't know as much about, or certainly don't know as much as we need to, is about the technical feasibility, particularly in relation to gas heating. And we don't know about the subsidies and other benefits that may be attached to the renewables options. So the key to our way forward is we need to do something, which we must, and the fact that we have a budget commitment to do so in place. The reality is the existing electric systems are going to have to be taken out. They don't perform, they are technically obsolete, and within 5 years, regardless of energy ratings, they would breach SHQS by being more than 20 years old. So a final word from the association's perspective before handing back, and this is to comment that we can't really take a decision in isolation. Any solution will have to be considered in relation to its implications for operation and maintenance, including lifespan to replacement and the life cycle costing implications of installing potentially very expensive kit. And there's also a need to consult our tenants, who we understand to be dissatisfied with the current situation, and they would expect to have some sort of input into decisions that will affect them. Again, those points I've just talked about, those 2 points, are the realities of how housing associations have to deal with this problem, these issues as registered social landlords. Well, hand back to Julio to conclude.
Just to conclude on some of the solutions that we looked at, and to kind of just from the study what conclusions in a more technical way we would come up with. I mean, various insulation options were looked at, but I mean, cost is always a concern. Obviously, working with the tight budgets that the housing association may have. Looking at aerogel materials, although are very effective and in some cases non-intrusive solutions, they're very costly. So it's obviously a concern from the housing association how much investment into those high-tech solutions to make, especially when there's other less costly solutions that can bring the standards just as low as the aerogel. So many solutions saved similar amounts of energy, as we saw in that graph, which was produced after the alternatives. And some of them were non-intrusive, which would also be taken forward. There was, in some of the solutions, the use of external insulation, which is preferred in many cases, but in this case, because we're dealing again with the shared ownership and the different tenancies, not all tenants would have agreed to conduct the work externally. So that's why we then looked at some internal solutions that would integrate into the housing association's flats. In terms of internal lighting using aerogel, we implemented that in the back elevations, mainly because there's a more reduced area to work in, and it's because of its thin properties, it could be very easily integrated into the linings and around different installation and pipework from the toilet, especially at the back, and various other configurations on those walls. Energy solutions depend on the level of intervention. Obviously, there's different constraints on all the alternatives, and there's different problems there in terms of cost as well. So a big focus on that has to be come out of this report and see what the next stage is. It's recommended to apply the more cost-efficient solution of replacing and maintaining the storage heaters. In terms of a more cost-efficient way, if possible, maybe in maintenance and looking at options of changing for more efficient current storage heaters would be a good option. Replacing the current hot water heaters with an electric device should make it more efficient, but again, a more electric boiler, etc., would also imply different pipework around the flat that would have to be assessed. The gas connection, I think, is an interesting option, which I gather is still in talks and would be explored in the future, especially with the incentive of installation. It's just really a matter of getting all of the tenants, both privately owned and other commercial units, to agree, which may seem quite a big task. So there's a big debate over that. Obviously, as gas would be recommended in Hamilton Road and not so much in Main Street, where maybe renewables or keeping with electric would be an option. That's the end of our slides. Thank you very much, and I think we'll follow with questions.
Well, thank you very much, Julio and Gavin. The presentation took a little bit longer, but it's very understandable considering complexities and very detailed investigations and proposals that you wanted to explain to everyone. So we have around 15 minutes for questions and answers, and there are quite a lot of them. We'll start from the first one, which was by Ken Mackey. It was a comment. He said, well, correction please, old storage heaters are 100% efficient at point of use if maintained correctly. Cost could be more a factor of maintenance. So that was the comment related to the beginning of your presentation of the current state of technology in existing buildings. But we can now start with the first question from Nicholas Heath. What were the respective thickness of the front and rear walls?
The front walls were sandstone. There were between 500 and 600 millimeters thick. There was an air gap of around 30 to 50 millimeters, and then the plasterboard. So overall, around 550 to 600 millimeters.
Mm-hmm. The question from George Alomakis. What is the cost of aerogel per millimeter and square meter, if you know?
I understand that for a 10 millimeter aerogel quilt, the square meter is around 25 and 36 pounds, 30 pounds, sorry. So that's kind of the cost per square meter. And that usually comes with a mesh that can then easily be rendered internally.
The question from John Council, can you explain why you selected SciMap, for example, in preference to IES or Design Builder modeling tool?
SciMap has been used by the Scottish Energy Centre for a long time now, and that's one of the reasons. And really, in terms of simple heat loss calculations and fabric alternatives, it's quite an easy and quick way of simulating.
Mm-hmm. A question from Alan Curran. Did you do in situ heat flux measurements to establish the actual U value, or did you just do a calculation? The value for the rear wall seems very high.
Yeah, we didn't conduct in situ U-value calculations using heat fluxes. It wasn't part of the scope of the study. It was modelled purely using SciMap. The back wall is quite high, but we must remember it's plaster on the hard, so it's really there's no plasterboard onto. It's a single leaf really. With both internal and external renders, so it's quite a big U-value.
Comment from Ken Mackey. This week's news: wholesale gas prices up 70%. Gas being rationed in Europe, so that puts a different view on whether gas is really the option.
Yeah, I mean, a lot of the there's a lot of debate whether gas is the future, especially when a lot of the renewable solutions are focused at electricity, for example, PVs and others. So although gas is going up, in terms of the current cost per kilowatt, it becomes quite a good option. Obviously, in the long run, that we might suffer from that. But,
okay. The next question from Roy Guthrie. Heat pumps are a good alternative to biomass in this situation without the logistics of managing fuel and with the benefit of clean air.
Yeah, I mean, the problem with heat pumps that we encountered on site was the ownership problems and just really trying to integrate it into the location. That was one of the. But yeah, I mean, Roy is correct too.
A comment from Michael Roy. Maintenance of the biomass boiler is also an issue.
Again, because it's a community heater, it would be maintained and managed by a third party. Most of the cases, that's how it's operated. And obviously that cost would be part of the whole scheme. But I mean, it depends on on the options and the way that we would set it out within all the apartments.
Question from Alistair Kant. Could you give the cost of the various fabric alternatives? It would have helped if this was on the slides showing the payback info. The slides will be provided. Perhaps you might add a slide or two.
Yeah, I mean, we didn't add the costs because there would have been quite a big list of alternatives and costs, but it's definitely in the document, and we could add some if the most representative ones, if that was an option here.
Okay. Question from or comment from George Lomakis. When it comes to biomass, one very important factor is the actual type of biomass used. Miss Kansas, for example, has a very high moisture content, which would make it inefficient to use if you cannot have a drying process.
Yeah, I mean, we're actually conducting some studies to do with the different fuel types and biomass and the moisture content of that. And yeah, it's a fair comment, definitely. It's worth considering.
A comment from Nicholas Heath. Heat pumps may not provide cost-effective heating without significant insulation beforehand.
Very true. I mean, the study would recommend, I mean, I would recommend obviously to deal with fabric intervention first, dealing with energy efficiency first as a core in the apartments, and then look at heating alternatives in order to keep that heat indoors as best as possible.
And Roy Guthrie agrees. He says, I agree, Nicholas, insulation has to be addressed first, as you also suggested.
Yeah.
Question from Edward Kelly. Is solar heating covered in RHI, Renewable Heat Incentive?
It will be, as far as I know, yes. It will be part of it whenever it comes into place this year.
Question or comment from George Lomakis. Solar water heaters can also be used as preheaters for water that feeds into conventional electric water heaters.
That's true. I mean, the temperature that would have been obtained from these thermal solar heaters would reduce gas use in a lot of these boilers. Obviously, from having really low water temperatures from initially to maybe boosting up 20 degrees or 10, 15 degrees would obviously use less gas.
Question from Ken Mackey. Have you factored in lifetime maintenance costs for each option?
No, we didn't explore the maintenance side of things, no.
Then a comment from Roy Guthrie. Solar thermal is covered by RHI at around 0.0 pence per kilowatt. The following comment from Alistair Kant. Just to clarify a point you made, your existing electric storage heaters do not fail under SHQS once they become 20 years old. This was a drafting error from the Scottish Government, which was clarified by them a couple of years ago. He says, I work with for RSL. Such heaters only fail if they were 20 years old when the SQHS regime was first introduced. Then a question from Nicholas Heath. Did you consider any other slimline wall insulation materials? For example, Space Therm, which is also a type of aerogel, or Sempatep, which does not perform as well, but is a lot cheaper. Also, the RHI rate for solar thermal mentioned above is for non-domestic. Nothing has been published for domestic rates yet, although the anticipation is it could be similar.
We in the report we didn't concentrate on products as independently, we looked at the material itself. That's how we simulated it. So Spacetherm is a company name, a product name, same as Synthetym. So we didn't want to mention products in the reports. We kind of had dealt independently. So that's why we. But aerogel is Spacetherm really.
Comment or question from Ragazzi. LHI for a housing association may be seen as a non-domestic. And then from Ken Mackey, Green Deal is going to favor insulation because it is always going to be the most effective first measure. Does the mixed tenancy bar this option for definite? It's not finished. So is it a mixed tenancy barrier in any way?
I think we discussed this.
Yes.
No, I don't know if you want to expand on it.
I think it's likely to be a barrier to any external insulation, because you would need both consent and the contribution from other owners who, in this building, taking the commercial other owners and the other residential owners together, are the majority.
Yes.
So I'd see that as practically an insurmountable barrier.
There is a question from Fiona McLennan. Is it necessary for all flats and shops to be connected to a community heating system? And did you discount the use of a gas boiler for such a system?
Not necessarily, but because of communal areas and bringing up a lot of the pipe work, they would have had to have consensus from all of the building users. That's the issue there. I would suspect that not all commercial units require gas, so that's a big debate there. So that's a problem with dealing with different ownership.
Question from Tessa Clark. For individual systems such as solar thermal or heat pumps, I think RSLs would be eligible for domestic RHI tariff. The non-domestic tariff would only apply to RSLs for communal systems. And one more question from John Stinson, three-part question. Was the energy consumption for the properties based on utility bills meter readings? That's the first one.
Yes, they were all. We obtained the energy bills from the housing association and through the tenant. So yes, it was real readings.
Did the housing association conduct any energy saving awareness campaigns to provide energy monitors and educating residents how to use heating controls before the study was conducted?
Yes, we had conducted an energy efficiency program a couple of years ago where all our tenants were advised how to use their systems. They all got the chance of advice on how to shop around, how to make the most efficient use of the energy in their houses. And we, in spite of that, end up where we were at the position at the start of this study.
And the last question from John Stinson is, will this be part of the building refurbishment upgrade strategy? Advice to tenants.
Ultimately, it has to be when any upgrading work is carried out, when any new system is put into a house, tenants have to be shown how to use it. It's reality, because people, regardless of the system, gas, electric or whatever, can't be assumed to just understand how to use their heating system.
Okay. Well, thank you very much. Let me check if there are any more questions. Two more. One from, just a second. My computer is playing a little bit. From Tom Edwards. Why, if the study underlines that these properties and others like them are completed uneconomic, are completely uneconomic, does the Housing Association not lobby for acquiring ownership, knock them down, regenerate, not renovate? Have you done the economic analysis?
No, we haven't done that economic analysis because there is no realistic possibility of that happening in terms of planning, in terms of ownership. It just would not happen.
Yeah, I mean, although they're not listed properties, there's some limitations on demolishing such properties.
Yeah. I mean, a decision was made within the last two decades to refurbish this building at Bellshill Town Centre for what was seen as good reasons at the time. They're not uneconomic in the sense that we can fund the work that's required to bring it up to current standards, and we still have absolutely no difficulty finding lots of people who need housing in the area and are more than happy to live there. So it's not an obsolete building in any sense.
Yeah, I mean, I would disagree in the way of knocking down before refurbishment. I feel there's more merit on refurbishing and looking at alternatives, and I think it's a more cost-effective and carbon-efficient way of upgrading and looking at the deficit in housing, definitely. There's so many properties out there, both occupied and unoccupied, current stock, that merit a refurbishment.
And we'll finish with a comment from Ken Mackey. Installation consent for resulting property upgrade may not be too difficult, especially if no upfront cost is required from the majority of occupiers under Green Deal. Something that should be further explored, at least a Green Deal survey be completed at the earliest opportunity.
Yeah, I mean, Green Deal is going to be quite a big bomb when it arrives, and there's lots of surveys these days looking at the options and the payback periods of these Green Deal solutions. So yes, definitely.
Well, thank you very much. We are now at the end of our seminar, and I would like first to thank both of you, Julio and Gavin, and to thank our audience online. Before we finish, just information about our future events. First of all, the forthcoming webinar on 16th of February entitled Environmental Design Teaching Model. It will disseminate the outcomes of the academic consultancy provided by the University of Edinburgh to IES Ltd to develop an environmental design teaching model that can be used in education of architects. The next event is a live conference entitled The Green Deal and Sustainable Refurbishment of Traditional Buildings, very much related to today's event. This whole day live conference will take place at Glasgow Caledonian University on Wednesday, 29th February.